Hi everybody, Mr. Rubo here. Today we're going to look at some examples for 2.1. So the first one we're going to look at is example 2. So we're just looking at here if the sequence could be arithmetic, which if you recall from the last video, arithmetic means it has a common difference, right? So it's going up by the same amount each time. So there's really kind of two situations here. We're given where we have a function given, right? It's written in the equation format, or we're just given the actual pattern of numbers. So both ways kind of have their own approach. And yeah, really we're looking to see, are we going up or down by the same amount each time? So what I would do for the function approach, at least initially, you might be able to figure this out once you kind of see some patterns and things we've talked about. So I would just plug in some numbers, right? So start with 0, 1, 2, 3, plug them in and get your answers, right? So 0, 0 squared, minus 3, negative 3. 1 squared is 1, minus 3 is negative 2. 2 squared is 4, minus 3 is 1. 3 squared is 9, minus 3 is 6. And then this will hopefully be enough to see that there is a pattern or not. So I'm adding 1. Here I'm adding 3, and then look at that, I'm adding 5. So right away, as soon as I see that, there is this is not arithmetic. And I spelled it wrong. There we go. All right. So you do the exact same thing for B, and I'll let you guys do that. The key is I'm online, so feel free to look at the key. But try B, and then for C, we'll go to see when you're given the pattern. Well, this time you're just looking like it's like you already have the y values of the table. So that's plus 5, that's plus 5, that's plus 5, and that's plus 5. They're all the same. We're all adding 5. So yes, it's arithmetic. And the common difference is 5. Okay. So D, same idea. So again, feel free to do it. Check the key. And yeah, let's go to example 3 now. So here we are given, we're told that it's an arithmetic sequence, and we're told a few things. So first, we're told a specific term. So we are told that the third term is 8. So you could almost think of this like a coordinate point, right? So 3 comma 8. And then we're also told that the common difference is negative 3. And we want to find an expression for a sub n and use the expression to find a sub 12. So with this is where we want to use the general form of a arithmetic sequence. So it's kind of like point slope form, if you will. So a sub n equals a sub k plus d parenthesis n minus k. So a sub n stays the same. A sub k is the thing they're telling us. So this right here is what we're going to use for a sub k, and the k in this case would be 3. So we're going to say a sub 3 plus the difference, which the difference here is negative 3, which we'll simplify that in a second, n, and then again the k is 3, so minus 3. And then a sub 3, though, we know is 8, so we're going to go ahead and substitute that in. Again, I'm going to simplify this a little bit. If I'm adding a negative, I'm just going to put a minus 3, and then n minus 3 is right there. And technically this is fine. You can also multiply this out. If you multiply it out and simplify, you'll get 17 minus 3n. So either one of those two are correct. Just realize it'll probably be the bottom one if it was a multiple choice question. So just keep multiplying it out. All right, and then the other part is a sub 12, which means we got to plug in 12, right? That notation is just telling you what to substitute in. So you substitute it in, and you get that a sub 12 is negative 19. Again, hopefully, multiply 3 times 12 and then subtract. All right, going on to example 4. Same idea this time, but this one doesn't tell us our difference. So there's kind of two methods you can go about doing this. Because it's arithmetic and it follows a linear pattern, you could think of these as, again, 2 coordinate points, and find their slope to find the difference, right? So that's 100% allowed. You can do this just like you would a linear function, right? So you would get 2 over 4, which is 1/2. Okay. The other way you could find the common difference when you're given 2 points like this is use that same formula we just did in the last example, right? So we got this guy, d n minus k, and you can let n equal one of the two numbers, so in this case 6 I made it, and then k would equal 2. So this is kind of our 2 different ways of doing this. And either way you do it, you'll end up getting the same answer, okay? For D, and then your final answer for a sub n. So once you do this, we would say a sub 6 equals a sub 2 plus D, because we don't know what D is yet, and then it'd be 6 minus 2. And yeah, we then plug in what we got. 9 equals 7 plus D, 4D. And we could solve this. So subtract, divide, and look at that. We get 1/2. Oh, my stylus there went a little crazy. 1/2. There we go. So we got the same D value. Either way, once you get what your D is, then you can do exactly what we did in the last example. And you could choose either of the 2 points. I'm just going to choose the one with the smaller number. So I'm going to say a sub 2 plus 1/2 n minus 2, and plug in that 7. So 7 plus 1/2 n minus 2, and distribute out. And this one worked out pretty nicely because that's going to be 1 minus 1, so I'll get 6 plus 1/2 n. All right, and so there is a sub n, and then a sub 24. Well, plug in 24. So that's 12. 12 plus 6 is 18. There you go. All right, last one here is this same idea as what we've just been doing with examples 3 and 4, but this time instead of given specific points written out, we are given the points in the graph. So again, a few different ways of doing this. You could think of them as coordinate points and do the work the exact same as what we were doing up above. So like 1, 6, 2, 4, 3, 2. This is 4, 0. Or just find the slope, right? I'm going down 2 over 1. So just from looking at that, I can figure out that my common difference is minus 2. Okay, I don't have to do anything extra. Okay, and actually, and I missed this point up here when I first looked, I also have 0, 8, which is really nice because that means my initial term, my 0 term, is 8, which means instead of using the one that I was using for all the others, I can actually use the one that's similar to like slope-intercept form. So the initial plus dn. So I get it real quick with this one. My initial is 8 plus negative 2n. Obviously, I can simplify that a little bit to 8 minus 2n. And there's my equation for this sequence. And then just like always, A17 means plug in 17. So you plug it in and simplify, and you get negative 26. Okay. Thanks for watching. Have a good day.